what we can do with that instrumentation or in a given application. So what we're going to talk here today is applications for safety, personal safety. Okay. Also the other equipments, like all this wireless instrumentation all the time. In this forum here, in the 4C, the vast majority of other applications that I develop involved is more on the environmental, like PRVs, heat exchangers, etc. But here we're going to talk specifically about occupational safety. Some slides about Emerson. Do you know Emerson? Yeah, you know. Okay. Yes. So I put here as the title as something related to the OSHA and for what's the best practices. So then we're going to talk about safety shower, and we're going to talk about also location awareness. Okay. And as I said to you, so we have many applications. So here's our safety shower, here's our location awareness, but we have other applications like monitor compressor, corrosion in the pipeline, heat exchangers, PRVs. Oh, this is, I would say this would be also another one for occupational safety because it is a H2S, O2 and CO detection, but pumps, fans, etc. So, Robert, do you have any experience with the safety shower? So, what's this? Could you tell me what do you work specifically with the safety showers? With you were a customer or you were?
We're contract.
Contract, right? And what's the big challenge when the safety shower that for concerns?
We personally don't have any big challenges. We actually perform safety shower inspection at some locations.
Okay. Yes.
The problem throughout the industry is the inconsistency of monitoring.
Okay. Yes. Okay.
You may have some facilities who have for years actually had a system in place of notification as soon as it's activated.
Yes.
And then you have some where we have, we've been able to find that lane.
Yes.
Some are not. They're not monitored. Neither have they been inspected on a regular basis.
Awesome. Okay. So so quality is better than quantity. How you state in the direction that we're going, because when we see the conventional safety showers, right? So we have either lighting or the siren, right? But here is what we're having seen, right? Beacon lights, like or just the radio, right? With the operator with the radio, or sometimes I've seen this customer hardwiring the safety shower to the DCS, right? So every month by regulation, right? So we need to open and close the valve, not just to check if there's water passing through, but make sure that the valve is functional. And how often do you see this temperature and process control in the safety shower? Do you see this?
That's important, especially in areas like South Texas. Southeast Texas, where temperature extremes.
Yes.
Number one. So that can prove the factor if somebody's got to get in. And
can aggravate the problem. Yes. Okay, but have you seen customers controlling the temperature? Yes. Okay, so they have that. Okay.
I've been to one facility where if you activate a safety shower, there is an all-call that goes out of the radio system. They're just that far advanced
on monitoring.
So there is an active emergency.
Yes.
That happens as a result of safety shower.
Okay. Yeah. No, that's the way to go.
They've gone beyond best practices.
Excellent. Yeah.
What I've only seen.
Yes. Same thing. That was the conversation that we have here. Typically, safety shower is absolutely a reactive in terms of projects. It's totally reactive. So first, unfortunately, they need to be exposed. The operation need to be exposed to a problem, and then say, "Oh, yeah, we need to do something." Right?
Right.
Yeah. So. Here's the problem or the vulnerability that we saw in this status quo here, right? So Beacon Lights and the siren. Well, we have to have another operator to see that, right? Otherwise, yeah. Radio, that I'd say that was the most surprising for me, the radio. Customer in general, they have that feeling and say, oh, I have radio, I just tell that, but there's a universe case that the operator is in distress. He have the radio, but he cannot tell where he is. Yeah. Or sometimes they take the radio.
Sometimes the radio goes with the uniform.
Yes. Yeah. And so this is give that feeling to the management or the operation that they're protecting. It's not. They're not. Okay. In a hard wiring, the safety shower, that's a solution. But the problem with that is the cost and the complexity to wire a safety shower is an absurd. So I think the solution, the real solution, is a fraction of the cost of the installation. Yeah, because the lay down cables. Think this: to lay down cable, think $100, and this number, this is before inflation, with $100 per foot. That's how much cost you bear cables and put communication cables. It's a lot. Okay. So then what happened? In general, Robert, what we see when we have customers hardwiring, they do like a group of safety showers. So they take like 3, 4, 5, 10, whatever is in that area, put that in the one, and then send that one cable back to DCS. So they wire a group. Yeah. So in whatever's into that group, that because cabling is extremely expensive for installation. Yeah. Okay, so here's another interesting point, right? So when you're inspecting, a lot of things on safety showers still being with the little tag paper, yeah, and in manual entry in the system. So it's people punching information, which obviously they can miss that, right? Well, and about the water system. Yeah, you need to control or monitor for water freezing or high pressure or hot water, as you explained as well in the application for customer. So, but like the pressure, water pressure is in the regulation as well. So they tell what the pressure, what's the temperature. It's all, but not necessarily that it's we see that. No, yeah. Okay, yeah, that's what I basically covered this, but that the false sense of security. And this was inspired in a real case in the Houston area, by the way. And yeah, I was operator with the radio. They couldn't tell where he was, and then took this to a lawyer to lawyer conversation after the fact. Yeah. So, okay. Now, one thing that is new, not new, that people doesn't understand or doesn't know. Okay. So what is what define response time, right? So since the operator pull the trigger, basically when he or she is pulling the trigger, basically the operator is trying to send in alarm as well as they have the 15 minutes of current water, whatever, right? But fundamentally, yeah, the one to see if there's alarm and people to help, right? So and then we have this discussion about what is the response time, what's reasonable. And interesting, on OSHA, you visit OSHA, there is on OSHA websites, there's a best practices. And then the best practices say, well, 4 minutes for first assistance, first aid. Okay? Like somebody been in the close to the person that is in the safety shower and give some assistance in basic support in about 15 minutes if it's a required more qualified assistance like a nurse or doctor or ambulance. So that was kind of an interesting information to understand because why? Because of this 4 to 15 minutes that we're talking here, depending on the case, that's what's going to, if there is an incident, that what is going to count during the litigation under this process, right? And this is quantified, so it's 4 minutes to 15 minutes, okay? Well, and then there's other factors that we're talking. So the temperature, so that's what the regulation asks. So here's the regulation, right? So 70 to 95 for eye wash. That's the pressure that is expected. Right? So, but anyways, that is the critical information here to say, well, besides this information, the other one was the cost to wire, as we saw before. So I already made my point here, that this one here, but if you're not comply with that regulation and not on time, I don't think there's any case that the employee have not find his rights with the court, right? So here's what our answer, right? Every safety shower, it should be connected to the system, not like a group, bunch of safety shower. That doesn't work because, well, yeah, of course, you're going to narrow down your search and see, but even that, though, it could be a roadblock or to accomplish with that 4 to 15 minutes. Okay? Oh, sorry. And again, this is some more details here to pinpoint, right? Well, what's the safety shower? And then another thing, well, when they're doing the routine verification, that say even that one that's once a month, well, the ideal is not collecting manual information, put in the paper and then punch that data. The ideal situation, what is sending that information electronically and have that entered that information electronically for not just for the reliability of the data, nobody misenter data, but even breaching the information. So I think the most neutral here for both sides, yeah, is to have this information being loaded electronically. Okay?
We
Yeah.
accomplished that at 2 of our sites. Conducting a test.
Okay.
So the inspection is a test of the system.
Okay. Yeah.
So it's automatically documented.
Yes.
And denoted as a
yes.
inspection.
Yeah. But does not rely on a piece of a paper. Yeah. That's the way to go.
So that way it's electronically.
Yes.
The site.
Exactly.
They're not depending
No, and the time stamping, matching with the result of that. Yes, perfect. Yes,
on reporting.
yes, yes, yes. Yeah. And the same water temperature. So it's very common. Well, let me take back. I'm not sure if it's common, but what we see in case so customer just put like the temperature switch to keep the water circulating. Okay, so that is something desirable. Or like where I am, Minnesota, so we're looking more for freezing water, right? So, but of course, yeah, that require water circulation as well, but for different reasons as here, right? Because here the problem is if the water's too hot, then you're gonna aggravate the situation, right? If it's above that temperature range. Well, in Minnesota, the problem is you might not have water, right? Because the pipe is gonna freeze, right? So yeah, keep the water circulating. Right? So this is the solution that Emerson found for this problem, right? Well, the solution is putting some transmitters, but in wireless. So let's take the hardwire installation out of the equation. Okay, so no wire because that will dramatically reduce the cost of installation. Okay, so we're going to do that in wireless. As you can see here, this is the wireless unit. Now, in conjunction with that, if you see here this highlight, so this is a electromagnetic switch. Right? And so that's the switch in the electromagnetic, say, actuator is here. So there's no contact with them, so, which also promotes the reliability of this switch, right? So and then the whole idea is if we pull the cord, so this little element here will be away from the switch and we'll send a signal. That signal, then we're gonna send that wirelessly, okay? And that for the safety shower, same thing for the eye wash station, okay? So yeah, now when we're transmitting this information, which is basically is nothing more than what the state of this switch, on or off. Basically, that's what we're saying. But along with that, well, now when the signal reach the system, it will gonna reach the system with the timestamp. So now we're eliminating not just the lowering the cost. So now your budget you're gonna be really used on the safety shower, not burying cables. And the second thing, now we're going to also add the timestamp. Okay. And well, there's other technologies from Emerson as well, along with the safety shower monitoring itself, which is monitoring the water pressure and the water temperature in the line. So that is a complements that you can add on the system. So yeah, that's pretty much the solution that we're proposing and we're using here with our customers. Now, we have another technology that called acoustic transmitter. So acoustic transmitter basically it senses flow on a pipe. Okay? Flow of a fluid. It could be gas or it could be liquid. So I have a customer and I say, oh no, I'm going to use this acoustic transmitter on the safety shower because, well, if the operator pull the cord, so there's water, and then if there's water, yeah, then we know, right? So that will do the alarm because the acoustic transmitter is kind of a temptation to use here because it's not intrusive. You just clamp that in the pipe and you're done. Okay, so there's no mechanical switch or mechanical arrangements that you needed to, right? Very simple. And I'm really big advocate with this acoustic transmitter technology, but for pressure relief valve and for the steam trap. And it was 100% against that solution. No, don't do that with safety shower. Well, why? Well, because if there's frozen water here in the pipeline, operator pull the cord. There's no water, and worse than there's no water, there's no alarm. And all that operator wants in this situation, well, is water, of course, but at least alarming, right? So that's how I was saying.
That eliminates the response.
Exactly. Exactly. So then we need to do a good judgment when we're using the technology, because we needed to accomplish with the two things. Well, the cost to justify the operation, but understand and say, can the system send the alarm, send in alarm electronically, right? So anyway, I just want to make that. And yeah, we have examples in many different kind of process industry. Yeah, so you can download this presentation, or you can read it through those examples. Yeah, that's what I have for safety shower. I'm going to transition now for what we call location awareness. This is kind of a new product. But any question here on the safety shower? Yeah. Are you good? Sure. Yeah. 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 I think you saw this slide from Doug White.
Yes.
Yeah. And, the interesting statistics, right? It's amazing how falls, slips, and trips is dominant. Yes. Yeah, it's something, right? So, and again, so was with Emerson, with the wireless group, of saying, yeah, there is a problem here to be solved. We need a better, we need a solution, right? Which is the one that I'm going to talk now, the location awareness. Okay? So, yeah, let me. So when we're talking about location awareness, basically, we're tracking. Basically, we're tracking people, and there is a lot of discussion here. Okay, what's the rights to tracking or when tracking people? What circumstances? What's the legal, right? Because we don't want to track people and know, oh yeah, you're in average, we're spending more time in the bathroom. It's very critical, this thing, right? So kind of reverse the situation, not tracking the person, but tracking the area where there's a hazard location. Okay, so it's not the say the wide, it can be, but that is depending how you configure the system. But we try to avoid and have a consensus where is really required to monitor, where it's not. Okay? So, but basically, we have three categories when we're have this location awareness. One is what we call the you have an area or called geofencing, right? So you have a big operation with distinct areas. So you can kind of map one area, say, well, this area, is mapped, but the next area, that's another deal, that's another thing. So it's a different area. So that's what we call geofencing, typically. So those clusters up there. The other one is the mustering station. So then we have something, not just to check how many people you have in the area, but when you really have a situation where you need to evacuate people, right? So that was the other, say, use case. And then the third use case, it's more like the sleep is creeps, etc. So then the person, and it, like the safety shower, it needed to send in alarm. Right? So that would be the three categories. Right? But when we're seeing this situation, right, and we say, okay, so what do we have in the terms of available technology on the market? Uh, is this solution really an industrial solution? And what's the cost to implement that? In the, the answer was not favorable because there's a lot of technology with tags, but they are for offices. They are not technology that we're talking a metal structure with mezzanines, where the communication signal, it has a lot of barriers to propagate. So to compensate that, conventional technology using, say, like a telephone technology, right? Or Wi-Fi, it got extremely complex for the infrastructure that you needed to have there to avoid all those blind spots, if you will. Right? So that's say, well, yeah, there is a bunch of people that have the tags, etc., but not exactly for the hardcore application and process units. So then we made a kind of a survey. We took, this is in meters. I'm sorry, but yeah, it's like say 300. Let's multiply this by 3 to do feet. Right? So it's a large area here. With this typical arrangement with pipes, etc. Then we found, okay, so if we're gonna conventional infrastructure, what's the access points that we needed to have in that area? Okay, and if we're gonna put a solution, that's the cost of hardware and software. That's the cost of engineering, and that's the cost of installation. So again, here's another case. Whoa, installation, because installation is a waste of money, right? So we want the installation as low as possible, but in this case here, installation is even more than the hardware and software. Right? So that's the number that we found for that area. So then we have this wireless technology, same that I showed you in the safety shower, the same that you use in the heat exchangers, pumps, or whatever, same. That wireless is not wireless like telephone. It's an industrial wireless communication called wireless HART, H-A-R-T. Okay. And so then say, well, instead of use conventional, how much would it cost if we use this wireless HART? Have the tags on a true industrial wireless network, right? And well, the first attempt was really good because while we were able to put the cost down on the installation substantially, and still using some kind of conventional wireless communication like the Wi-Fi. But then we went a little further, and then we found one that's totally 100% industrial communication, and that it drops much more the installation cost. So we came from this to this, And because we're have the possibility to redesign all the software and the hardware, we also were able to push down the cost per tag. And that was how they end up the solution. Okay? So we have this portable tags or personal tags. Right? So these tags, they're going to be embedded on these anchors. So the anchors, but let's imagine this room here would be that area that I show in the picture. So we're going to put anchor, and we're going to do a kind of a grid. So this anchor in this grid, which is this anchor here, this that goes into this wireless industrial network is the same industrial network with this process industry. They already have. Okay? So we're just adding something else on that. Okay? So we have the anchors, and then those devices here, they're going to flow under this grid that we're talking. In this anchors, it helps with the elevation because it's very simple to install from one floor to the next, to the next, to the next. So now we have the 3D that typically we don't have with conventional. So, and this is the conventional, this is the mix, and this is the safe configuration with the wireless hardware. Oh, we're just repeating the same slide, sorry. Okay. And here's the kind of how it looks like the software that I was telling you. So geofence, you see each area here is, yeah, you have a specific coverage. So then why we do this geofence? So on the system, you can track, for example, well, in this area here, we can have only 10 people. Okay, so if the 11s show up for the party, say, oh, it will send a kind of a notification of the system. Right? Or you can say, you can make a configuration, say, well, in this area, you can have 10 people. However, no more than 3 contractors. Well, same thing, right? So you have like, you have 7 people, but the 4th contractor came here. No. So we'll send the notification. That's the geofencing. Right? Well, the second use case that I told you, the safety mustering, so is for a situation where, oh, now we're in the fire drill. Well, we need to do something. So then you have the designated mustering station. Yeah. The big problem that we saw with this mustering station, everybody needed to badge. Yes. Or everybody's so nervous or excited, forgot to do that because, oh, no, I'm here, and then to tell the case what they did. So that is, we'll eliminate this because just a person being on the mustering zone, meaning it's checking. There's no reason or there's no action to be taken. That's all. Safety alerts. Today, the safety alerts is only about, say, a button. Okay, so the person needs to hit the button. But we're enhancing this technique. That's the first iteration of this. And so we put that. But idea here in the roadmap is to add like H2S sensors, put more sensing on the stacks. And that's called the
safety
yeah.
alert. The safety alert.
Yeah.
So the alerts, basically a person's elevation changed, the level didn't change. So it says this person's down based on their elevation change?
No, this is only, for now, it's only like, yeah, just a button. A person, we're gonna press a button for now. We had that idea to have the person false. The false positive of that thing is immense, right? Because there's a like Apple, they have that main down, right? But there's complication. It's beyond my knowledge exactly on what is how this false positives done, but that's an issue right now. Okay, whether the false positive, but we're evolving that. We definitely want to have the sensor. So that's why I would say now let's put the just for legal things. Let's put for now just the bottom. But that's where we're going. And then, as you can imagine, just to close it here, the presentation is, yeah, we're going to have that integration, right? So the safety shower in other applications. Anyway, that was